Okay, this should be the final section on that very old worksheet that we were talking about. Okay, uh, with the discussion of this, you should be clearer about how to find principal values. Hopefully. Okay, there is an additional question by one of you on roots of equation or discriminant. Okay, we'll discuss last. Now, evaluate without a calculator. Why they say evaluate with a calculator? Because actually, with a calculator, you can actually find the answer for this particular question. What do I mean? Okay, so if you turn on your calculator, then let me see. Did they ask you? Okay, they didn't ask you for whatever. Okay, wait. You press cosine. Okay, you press exactly what you see. Then you press inverse tangent. Then you press minus 8 over 15, right? Then you close bracket and then you close bracket. Okay. Then this calculator will actually give you the final answer already. You see, this calculator, right, will give you the final answer already. My working here, as you can see, the final answer is 15 over 17. Final answer already. But of course, because they say without using a calculator, that means they want you to show them how to get it without using a calculator. Okay, so I'm going to teach you how to do it. Now, the very first step, if you remember, right, is we always change this irritating thing, or this complicated looking thing, right, to something that doesn't look so complicated or irritating. Okay, if you cannot recall, I refer you back to when we first started on this worksheet. Remember, this one looks very complicated, very irritating, right? Doesn't it look very irritating to you? Okay, so we let x be this. We can let A be this, B be this, any alphabet you want, okay? The whole idea is to, after that, sign both sides, and then it doesn't look complicated with this sign inverse there. Alright? And it works especially well, or is very effective, especially for such questions where they look so complicated. Alright? So what you do, you let this whole thing with the tangent inverse one be any alphabet you like. So I let it be A. Why do we want to do that? So that we can tangent both sides and end up with a less intimidating, less scary looking ratio. Tangent A equal minus 8 over 15. Not scary at all, right? Okay? But you must remember that when we do this kind of questions, right, which involves tangent inverse, we are dealing with principal values. Okay? And principal values has certain range. Okay? And when we talk about tangent, okay, the range for tangent, remember tangent is what call that, like a cubic graph like that. Tangent, right, is from minus 90 to 90. Okay, so it's in the ASTC, minus 90 to 90, so it's in the first and last quadrant. Alright, and because this is a negative, it has to be in the last quadrant, because in the first quadrant they are all positive. That is why I draw this in the last quadrant. Okay, and you see opposite over adjacent. This is the angle we're talking about, right? Opposite over adjacent. Opposite over adjacent, opposite over adjacent, 8 over 15, right? How do I know that the minus belongs to this fella? As I told you in the previous lessons, this minus can belong to this 8 or can belong to this 8, depending on what? Depending on the diagram you have. Yeah, so this minus here is minus because this is, this coordinate here, right, will be negative something because it's below the x-axis. Okay, that's why this minus belongs to the 8. and not to the 15. 15 here is positive one. Okay, so you must get this correct. You will get marks for getting this correct. Okay. Now after you've gotten this diagram, you can use Pythagoras theorem. No need to show working, just press calculator can get 17. Okay. A maths, this kind of trivial things, right? No need to show working. Okay. Then they want cosine of this, right? But isn't this your A? And isn't your A this so-called A? This angle A is this one. So we are talking about this angle lah. So isn't it adjacent over hypotenuse? Which means that your cosine of your, this is A is this finish. And does it match the answer that we got just now on the calculator? Okay, so this kind of questions they may look very difficult, okay, but they are not. Why no? Because in the very first place, you can check your answer using calculator. In the second place, you just need to put up a show to know that you know all this. Okay, finish. Now, how about this one? This one is even easier. You got trigo ratio, got the equation. You are supposed to solve trigo equation. So you use the very famous law, or sorry, this method called AddMath. Equivalent form ready? Oh yes, it is. Equivalent form ready, but not but wait, you need to check domain. The domain is 2x. Sorry, the domain is here. You need to check. Oh, I need 2x plus pi over 3. Like this is the argument. I need 2x plus pi over 3, but what they give me is x only. So what should I do? You must, wait, I calculated here already. You must change this to 2x plus pi over 3. Meaning to say, each of these you times 2. Times 2 here is still 0. Times 2 here is 2x, right? To get this 2x, okay? Times 2 here, get 8. Alright? Then I want the plus pi over 3. So you press calculator, plus pi over 3. Write in decimals, okay? Because pi over 3, you don't know exactly what's the value. You write in decimals. That will help you to determine what to reject or accept later. Okay? Same here. Plus pi over 3, you get this, which is exactly what we want. So we have achieved our this domain already. You know what I mean? So this domain and this domain, they are different. This domain, right, is talking about this fella, what we're given. The final domain, okay, is the x. Does the x fall within 0 to 4 or not? You see? Yes, it does. Clear? Okay, so I haven't finished here. I must plus pi over 3. 8 plus pi over 3 is this one. You press calculator and check, okay? After we're done that, we are going to now E done already, D done already. Mode. You see, now here no degree, right? That means it's radian already. That means it's 0 radian, this is 4 radian. Okay? Then alpha done already. Then ASTC. Okay, let's do the ASTC. We want the sign to be positive. So where should it be? Here and here, okay? And what is it? Domain, right? Okay, later you check. Okay, but now we are doing for 2x plus pi over 3. This alpha refers to this, okay? It's not referring to this because now we are solving for this first. That's why we need to work this out to find out where to stop. Okay, now this part here, you listen carefully. Some of you may have problems understanding. This is my alpha, right? So it's 0.33984. Correct? 0.33984. But it does not fall within my domain. my domain using just now what I have found 2x plus 3, right? Why 2x? 2x plus pi over 3. Why? Because that's what they give me. Okay? Based on this, my so-called range, right, must be from 1 point something to 9 point something. I cannot accept this, cannot make it, cannot accept. Oh, that's why I never write here, lor. I didn't accept. Then you say, huh? Can like that? Yeah, can like that. Okay? So, why I put a tick here? ASTC, right? It should be here and here, right? Sorry. This one cannot, So, the next one should be here, right? In the second quadrant, which is the obtuse angle. So, you take pi, which is 180, minus this alpha, which is 0.333, whatever. So, that's how you get this value. Then you check, pi minus 0.33984, right? It's 2.8 something. Is 2.8 something lying in between this and this? Yes, sir. Yes, that's right. Yes, then leave it. Okay, leave it. That means we can accept this. Okay, now, in the first cycle, normally when there's 2x, is you can go 1 round, go 2 rounds because of 2x, okay? So now, in my first round, I find that I cannot accept this, but I can accept the second quadrant. Okay? Now, can I go one more round? Now, one more round, you must be careful. This value, this alpha, right? The first round cannot, but in the second round, can or not? In the second round, can, right? So it's this plus 2 pi there. That's why I wrote here. This plus 2 pi plus alpha. Why can? Because you press calculator. Two pi plus this, right? It can work. It's 6.6 something. So 6.6 something falls within this range, right? So it is perfectly fine. We are solving for this, okay? Later to get this, right, we minus pi over 3, minus pi over 3, minus pi over 3, every one of them minus pi over 3. Then everybody divide by 2, divide by 2, divide by 2. That's how I got these 3 answers, okay? But one of them must be rejected lah. Okay, okay, then now you see, you see this fella, at first round cannot make it, right? Doesn't fall inside this range, but second round can make it. How about this fella? First round can make it, then I go another 360, which is 2 pi. So I add 2 pi to this. 2 pi plus pi is 3 pi, right? Then I take 3 pi minus this. I find that cannot make it. Cannot make it. What do you mean by cannot make it? Okay, sorry. Yes, you take 3 pi. 3 pi minus this, right? You will find that the answer is 9.08 something. 9.08 something, but I'm supposed to start at 9.04. So this fella cannot make it. You reject it. Okay? So there are only 2 possible answers. Now let me repeat how to get from here to here. Don't you agree to get the x, you must minus pi over 3, then divide by 2. So this one you must minus pi over 3 divide by 2 to get this. Minus pi over 3 divided by 2 to get this. So there are 2 answers. Alright? Okay, I hope you are clear. This is considered a difficult question. But they are very nice. They already give you the sign. Okay? Tired, Okay. Never mind. We finish it, okay? Sketch the graph of this and this. I told you before, if you have tangent and sine or cosine graph, right? You do the sine or cosine graph first. Why like that? Because sine and cosine graph, they have more curves. Okay? They have more turning here, turning there, right? So you want to settle that one first, then it's easier to fit the tangent inside. Okay, so let's start this off. Oh, this is a very simple one. There's no center is 0, so it's just the x-axis, right? Okay, and now next step is 4. So 1 2 3 4, 1 2 3 4. Remember minus, minus. Okay, so your maximum is here, minimum is here, center is just at the x-axis, so no need to draw. Okay, clear already. Okay, now you see, there's a minus here. So actually what it means, right, is that instead of going quarter of an egg, it will go quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. It will be a flipped graph. Okay, but if you don't know, as I mentioned to you, just use calculator and press sign 0, then slightly more than 0, then you will know where it goes. Okay, the period you need to find, that's 2 pi over 2, that's pi. Okay, and you're supposed to draw from 0 to pi. So same thing, I label pi here, I label 2 pi here to tell myself this is my ending point. Okay, I think it's slightly off. Can okay, so I do one round first. So I halfway. Okay, don't you see it's always the same, 1/4, 1/4, 1/4, 3. Okay, so if you don't know, right, press sub 0 inside here, you will find that you get 0. So this is your starting point. Then you press slightly more than 0. Okay, maybe you press 0.5 or 0.2 or whatever. You will find that it is a negative value. That means it will be here. That means your quarter of an egg will go quarter of an egg here, then here, then here, then here. Okay, now here too sharp already. Quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. One full cycle already. Okay, then same here, divide into 4 parts. You know plus 1/4 pi, right? So this will be like that. Okay, use your calculator to help you. Then this will be the quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg. So it will be quarter of an egg, quarter of an egg, quarter of an egg, quarter. Finish already lah. Where quarter here? Finish already. Haven't finished here. Haven't finished. Sorry. This one not erase one is. Yeah, that's why you should always use pencil, don't use pen like me. So this is your minus 4 sine 2x. Label it, must label. This will give you marks already. Okay, now your job is to find or draw this fella. This fella, wow, we seldom draw this fella. Okay, this fella is very easy to draw. You know that the period is not 2 pi over n. Tangent is the odd one out. Okay, it's pi over n. N is a number here, so it's 1, right? So it is just pi. Okay, period equal pi over 1 equal pi. Meaning, what does it mean? It means that I always take reference from here. It's a cubic graph, right? We're revising cubic graph now also. It means that here to here, which is one full cycle, right, is pi. So if it's pi, this must be minus pi over 2. This must be pi over 2 to make up pi, right? So you bear this in mind, right? Then pi over 2, this will be where you draw the asymptote. Remember? Asymptote. Remember? Okay, then pi over 2 and another pi over 2, you draw another asymptote. So that this whole distance from asymptote to asymptote, right, is pi. Okay? Then now how? From here to here is pi over 2, right? But there's another asymptote here, so cannot reach already. Never mind. Okay, so you know how to draw or not? By right, it is like that, right? From the negative go to 0, then positive, right? But because you're not supposed to draw from negative, there. They only ask you from 0 to 2 pi. So you imagine you're drawing from negative. Don't draw, imagine only. Then here, then you okay, like that. Okay. Then now can. This is like the center, then this is the ending, okay? So imagine you're drawing a cubic graph. This very badly drawn. Okay, then this one, imagine you're drawing a cubic graph. Should be more curve here, okay. Like that, go up, right? So that's it, finish. So can you see that there's one intersection here, 2 and 3. Alright, so if they ask you to solve, no, not solve, find how many solutions, right? It is 1, 2, 3. Okay? So now, as expected, they say state the number of roots. Number of roots means number of solutions for this. Now, always have to arrange it such that you get this on one side and where's the other one? I labeled wrongly, terrible. Okay, this is tangent x. Tangent x. So tangent x is here already. So you get lost. You go to the other side. So then I showed the working here already. Here. You get lost, go the other side. Isn't this one of the curve? Y equal this. And isn't this the other curve? Y equal this. Okay? Then you see how many solutions just now we counted 3, right? 1, 2, 3. Finish. Okay? And finally, this one. They're trying to make life difficult for you. Okay? If x is between this and this, but this and this not shown on the graph, not shown on the graph. So you must make some predictions. How? Okay, now you must understand. Okay, this you read the question first. State the number of roots for the equation, this one. Okay, this equation, right, is the same as this equation, right? So they are actually the same thing. The only thing that changed is the range here. Okay? Then they say justify your answer without solving. That means they don't want you to solve. They don't want you to use AddMath to solve this. They don't want. So they only want you to explain using what you have here. Okay, so very simple. You just tell them, I already know what between 0 to pi, 2 pi, for, okay, I split into 3 sections, for 0 to 2 pi, 3 solutions. Okay, you tell them part 1 shown already, part 1 shown already, 3 solutions, right? 1, 2, 3. Okay, now you imagine if this had carried on. See, I told you quarter of an egg, quarter go on forever, right? Quarter go on forever, goes on forever. So we need to go another pi. That means we need to go another pi. But I ask you, how will this graph look after this? Don't you agree that it's going to go quarter of an egg, which is here, then quarter of an egg, which is here, then quarter of an egg, quarter of an egg, quarter of an egg, quarter, until here? Isn't that pi? Yeah, so it means that this section of it, okay, you like cut and paste. You don't need to draw, you just think that it's here. Okay, this point is this point, so don't count anymore, But this point, which is somewhere here, one more solution. So from 2 pi, cannot count anymore, cannot include to 3 pi, right? One solution. That's what they want you to be able to see, you see, from here, right? This part, you think about it, it's a continuation here. And there's one more solution exactly at the pi. Okay? Why don't count this point here? This point already counted lah. Already counted just now here. Between here to here we already counted there. We counted already. So cannot count anymore. Okay, I hope you are clear. Now we are going to do the negative values. Okay, for again cannot include the zero because down here the zero already included here. This point I already counted this point under this section, right? So don't count, don't double count. Yeah. Okay. Now how to do this? Now don't you agree that this fella, if I were to continue, right, it'll be quarter of an egg, quarter of an egg, quarter of an egg, quarter of egg, the blue graph. Isn't it this part? Quarter of egg, quarter of egg, quarter of egg, quarter of egg. So actually it is it is pi, okay, then another half pi, is minus 1.5 pi to the left, right? So you imagine you start here and then you come here, right? It is actually this part here, It's actually this part here, right? I cut this part, and paste here is exactly the same. But now imagine this part is at 0 here. We don't count this point anymore. Why? Already counted here. So now we count what? We count here. Okay? That means there's one more point here. So one solution. Therefore, total 5 solutions. Finish. Okay? Yeah, not an easy question, quite difficult. You don't understand, then you ask me, okay? Okay, finally, somebody asked this question, so I'll just do this question. It looks difficult, but it is not difficult at all. Why not difficult? You see, given that this is never negative. Now, what's the meaning of never negative? A happy face, like that, right, is never negative because it's always above the x-axis, so its y value will never be negative, correct? That's how you may ask me, if it is just touching, that means the y value is 0, right? Is it called never negative? No. This 0 is not negative and is not positive also. So is never negative. When we say never negative, can we include 0? You think about it, you think about it. So which means do I put the equal sign here or I don't put the equal sign here? Because what I'm trying to say is, do I accept equal roots or not? Is it considered never negative? So is the whole idea is this, you got to think, is y considered negative or is it considered positive? Okay, so I show you this solution, you go and think about it. Okay, we can discuss in class, but the other condition is this, it must be a happy face, right? Okay, so k must be positive. Okay, and then later you combine with this other inequality and then you get the final answer. This inequality, you go and think about it, can it be equal to 0 or not? Okay, then we will talk about it another time. Okay, in class, so k equals 0, you see, k equals so k greater than 0, so I put 0. Greater than 0, no equal sign, I draw here. Okay, then this is between -1 and 9. You think about it whether there should be an equal sign. So it's here to here. Overlapping part is here. So it's between 0 to 9. Like that, like that. So can you go and think about it whether should include or should not include? Okay, yeah, so that's all for today's video. All covered already, that very old worksheet. Okay,